Okay, so I'm just finishing up the last video, and the point here was just to do a little bit of algebra to show this last step. That is, if you have the differential equation x prime equals ax plus b, can we convert this to just x prime equals a times x with a different a? In fact, I'm going to have a change of variables here too. Change of variables. Okay, and so how am I going to do that? Well, our book actually talks about doing this. We're going to let, so I'm using this particular matrix here, right? Maybe I should rewrite that down below here, just so we can see what's happening. dA over dt is going to be our, I lost my place, minus 6 over 20 over 50 a plus 1 over 25b plus 24. Getting too sloppy. Maybe I'll pause and write this down. Okay, so before I get too far ahead of myself here, oops, I wanted to do one more change there. I just wanted to rewrite what we had before. Here's our two differential equations, and what we did is we solved for the equilibrium solutions, which meant taking the derivatives equal to 0, and from there I found that a star and b star are the solutions, 1800 over 7 and 1200 over 7. And so that means that this a star and b star solves this equation, right? So we want to remember that because that's our equilibrium solution. Okay, and so now I want to let u be equal to the variable a minus a star, and v I want to be equal to the variable b plus b star, b minus b star. And now I want to find the system of DEs for u and v. Okay? Well, first of all, we see that u dot, or u prime, we'll just use a prime, is equal to a prime minus 0. So therefore, u prime is just equal to a prime. And a prime I can go ahead and write down as minus 6 over 50. And in place of a now I'm going to write down my my substitution there. That's u plus a star. And then that'll be plus 2 over 50 times b plus b star plus 24. Okay, and then similarly v prime is going to be b prime, which is 6 over 50 times u plus a star plus, minus 9 over 50 times b plus b star plus 0. Good. Now let's simplify these differential equations here, and we get that u prime is equal to minus 6 over 50 times u plus 2 over 50 times b plus, I want to separate this from the remainder here, and the remainder is going to be minus 6 over 50 times a star plus 2 over 50 times b star plus 24. And I write 25 for some unknown reason. And then v star, v prime, it's getting late. I'll see if I can make it through here without making too many errors. 6 over 50, I'm already making them, minus 9 over 50 times b, because I want to rewrite these just the way I did here before. 6 over 50 times a star minus 9 over 50 times b star plus 0. Now notice that right here, do you see what you're looking at? Is this, and so that is equal to 0. Well, 0, 0. So this box right here is equal to the vector 0, 0, and so therefore this entire thing just ends up being u prime, well, I could rewrite it shorthand, uv prime is equal to 1 over 50, and then we have our matrix back, minus 6, 2, 6, minus 9 uv. And so now you see what we were after. We were after this derivative just equal to a matrix times a vector. And so that's going to come in handy later on. So again, the idea is that if you have a system of equations and the system is linear like this, what you can do is you can shift the system by the equilibrium solution. So here we're just shifting coordinates. You can shift coordinates so that your new coordinates have the equilibrium solution at 0, 0. So what we did here, you could think of this as like xy, and the equilibrium solution was sitting over here. But then we create a new set of coordinates, u and v, so that 0, 0 is the equilibrium solution. Okay. All right. So that was fun. This is a very similar exercise to what's in the book. So this is the algebra that was involved. I think that was all of the homework hints that you might need before turning in the homework. Okay. Remember, I think, read over the emails that I'm sending out. We may be meeting live pretty soon. It's always good to meet live at least a couple of times through the semester just to say hello and see who's in the class. All right, I'll talk to you later.